So today we're going to be looking at stoichiometry. Our syllabus outcome is to conduct an investigation to determine that chemicals react in simple whole number ratios by moles. So here's some revision questions. Moles cannot be directly measured, so are usually calculated using something and something else. And the equation that relates mass, molecular mass, and moles is this. So do those, pause the video, do those, come back. Right, now that you're back, let's have a look. So moles cannot be directly measured, so usually calculating using mass and molecular mass. The equation that relates them is N equals M over MM, where N is our number of moles, M is our mass, and MM is our molecular mass. So, stoichiometry. What are we dealing today? Stoichiometry is defined as the relationship between the relative quantities of substances taking part in a reaction or forming a compound, typically a ratio of whole integers. What this means is that during a reaction, our molecules react in set amounts that, when simplified, form a ratio that's equivalent to the coefficients of reactants or products in a reaction. So I should say reactions and products in a reaction. Basically, it helps us calculate and predict mass quantities of reagents that we use in a reaction. To do this, we need only the moles or mass of one of the reagents and the balanced equations. That's the key thing there, is making sure that the equation is balanced. If it's not balanced, it's not going to give us accurate results. So, let's have a look at the following equation as an example. Here we have calcium metal reacting with hydrochloric acid to form calcium chloride and hydrogen gas. Okay, we see in the above balanced reaction that we have a stoichiometric ratio of 1 to 2 to 1 to 1. And this is coming from the coefficients in the reaction. So we have 1, remember, if we don't have a number, it counts as a 1, 2, 1, 1. So that's where that ratio comes from. That's very important with the rest of with our stoichiometry. Now, why is that important? Because if we started with 2 moles of calcium, the ratio would then be 2 to 4 to 2 to 2. Okay? Basically meaning that if we start off with twice as many moles of calcium, we need twice as many moles of hydrochloric acid, we get twice as many moles of calcium chloride, and produce twice as many moles of hydrogen gas. But what if we started with 0.0389 moles of calcium? Now, I'm sure some people would be able to go, oh, that's easy. Just double it for the second one. Okay. That's all well and good for this question, but there are other ones that get harder in the long run. So in the meantime, what we're going to do is use what we call the unitary method. Now, those that paid attention in Year 8 maths would know what this is. Basically, it's a method, it's a mathematical technique used for problem solving by first finding the value of a single quote-unquote unit, and then multiplying that number by the necessary ratio to find the correct value. Basically, in the last example, calcium, it had a stoichiometric ratio of 1. So that easily could count as our unit. Okay. So again, having a look at our reaction, it was 1 to 2 to 1 to 1. If instead we had 1 unit was equivalent to 0.0389 moles, then the reaction with a stoichiometric ratio of 1 to 2 to 1 to 1 gives us 0.0389 to 0.0778 to 0.0389 to 0.0389. It basically means if we start off with 0.0389 moles of calcium, it's going to need to react with 0.0778 moles of hydrochloric acid to produce 0.0389 moles of calcium chloride and 0.0389 moles of hydrogen gas. Now, let's have a look at another example. Consider the following equation. Okay, we have one there. It's CH4, which is methane, reacting with oxygen to produce carbon dioxide and water. Okay, so this is just combustion of methane. If we have a look at it, the rest of the question, if 0.865 moles of methane is used in the reaction, how many moles of water are produced? Well, we can see that methane has a stoichiometric ratio of 1. Okay, so if it's got a stoichiometric ratio of 1 and there's 0.865 moles of it, then 1 unit is 0.865 moles. Water, it has a stoichiometric ratio of 2. Therefore, in this reaction, it will produce 2 units of water. Now, 1 unit is 0.865 moles, so therefore 2 units is 2 times that number, so 1.73 moles. So basically, how many moles of water are produced? The answer is 1.73 moles. Now, having a look at another example. So consider the same equation. Okay, so we've got that combustion of methane again. If 0.364 moles of oxygen is used in the reaction, how many moles of carbon dioxide are produced? Now, this is where it starts to get a little bit different, okay? Because, having a look, oxygen has a stoichiometric ratio of 2. So it's got that 2 out the front. Okay, so what that means is it is worth 2 units. Okay, so what we need to do is we need to divide that number by 2 to get how much a unit is worth. Okay, so 1 unit is equal to 0.182 moles. Carbon dioxide, on the other hand, has a coefficient of 1, so it's only going to have one of those units. So it's going to produce 0.182 moles of carbon dioxide. So now look at another one. So this one's a little bit different. I've gone something a little bit fancy here. So we've got magnesium metal reacting with phosphoric acid to produce magnesium phosphate and hydrogen gas. Now I chose this one because it's got a nice wide range of coefficients. So we have 3 magnesium metal atoms reacting with 2 phosphoric acid molecules to give us 1 magnesium phosphate and 3 hydrogens. The question is, how many moles of phosphoric acid are required if 0.768 moles of magnesium are used in the reaction? So what we do, we have a look. Magnesium has a coefficient of 3, therefore it's equal to 3 units. And so 0.768 is 3 units, so we have to divide it by 3. So 1 unit is 0.256 moles. Nice and easy. The question is, how many moles of magnesium are used in the reaction? How many moles of phosphoric acid are required in the reaction? So phosphoric acid has a stoichiometric ratio of 2. So it's 2 units. So what we do is we take our value for a unit, so 0.256 moles, we multiply it by 2, and we get 0.512. So what that means is that the reaction requires 0.512 moles of phosphoric acid to go to completion. Okay? So try it yourself. The following reaction, so 2C2H6, which is ethane, plus 7 oxygens gives us 4 carbon dioxides and 6 waters. Okay? So it might look a bit off-putting to begin with, but it's the same process all around. It's actually quite simple. How many moles of water will be produced if 1.34 moles of oxygen are used in the reaction? So pause the video here, have a go, and if you're not quite sure, come back and we'll work through it. So the answer is 1.15 moles. How did we get there? Well, 1.34 moles is equal to 7 units. So remember, how many moles of water will be produced if 1.34 moles of oxygen? So that 1.34 is equal to 7 because our coefficient of oxygen is 7. Now what's going to happen is we want to find 6 units worth. So water, so our question mark moles equals 6 units. So what we do, we divide 1.34 by 7, and that'll give us the value for 1 unit. So let me just pop that into my handy calculator. So 1.34 divided by 7, that comes out to be 0.1914. So that's the value for 1 unit. If we want 6 units, we just take that number times it by 6. And we end up with 1.1485, which actually rounds to 1.15 moles. Okay, so it's basically 0.1914 times 6 gives us so it gives us 1.1485, which rounds to 1.15 moles. Okay, so hopefully you got that now. Summary, so stoichiometry is the relationship between amounts of reagents used in a reaction. Given one mass or moles value, you can determine the number of moles for all reactants in a system. Today we're just focusing on moles, not mass, that'll be the next lesson. And these can be determined using the unitary method, so where we find the value of 1 unit and we can compare that. Okay, so that's all for today, so please move on and do the worksheet. The answers should be on Canvas if you need them. And if you have any issues, please send me an email. Thank you.